Welcome to the DIY Honda Garage channel. The DTC P2413 indicates an EGR, exhaust gas recirculation, system malfunction, specifically in the Honda Pilot models spanning from 2016 to 2022. This diagnostic trouble code, DTC, is generated when the engine control module, ECM, detects that the EGR system is not functioning correctly. The primary component involved is the EGR valve and its associated sensors, which are responsible for recirculating exhaust gases back into the intake manifold. This process improves combustion efficiency and reduces emissions. In the Honda Pilot, the EGR system is located generally near the intake manifold, where the valve can be accessed for inspection and testing. Proper functioning of the EGR system is essential for maintaining optimal engine performance and compliance with emissions regulations. So addressing DTC P2413 promptly is crucial. In the context of DTC P2413, the EGR system comprises multiple vital components, including the EGR valve position sensor, and relevant wiring harnesses. The role of the EGR system is pivotal. It recirculates a portion of the exhaust gases back into the engine's intake system. This mixing of exhaust gases with the incoming air-fuel mixture lowers combustion temperatures, which helps to reduce NOx, nitrogen oxides, emissions significantly. The EGR valve itself is typically located near the intake manifold, making it an accessible component for service. The valve position sensor monitors the valve's position to ensure it opens and closes appropriately, while connecting wiring must remain intact without shorts or opens for proper operation. Any malfunction in this system can trigger DTC P2413, signifying the need for immediate diagnostics. Several potential causes could lead to DTC P2413 being triggered. Firstly, a faulty EGR valve itself might fail to open or close appropriately, resulting in insufficient recirculation of exhaust gases. Secondly, wiring issues such as frayed wires, shorts, or open circuits can disrupt the electrical signals necessary for the EGR system's proper functioning. These flaws could affect either the EGR valve or its position sensor. Thirdly, a malfunctioning EGR valve position sensor could relay incorrect data to the ECM, thus impacting the EGR valve's operation. Identifying these causes is critical, as they directly influence the integrity of the EGR system and, subsequently, the vehicle's overall performance and emissions compliance. When DTC P2413 is logged, specific symptoms may become apparent, indicating that the EGR system is malfunctioning. One primary symptom is the illumination of the check engine light on the dashboard, alerting the driver to a problem with the vehicle's emission system. Additionally, rough engine performance, including stalling or hesitation during acceleration, may occur due to inadequate exhaust gas recirculation. Drivers might also notice a significant increase in emissions, often leading to noticeable exhaust smoke, which can contribute to vehicle inspection failures. Addressing these symptoms should be a priority, as they may also lead to more severe engine performance issues if left unresolved. For the first troubleshooting step in addressing DTC P2413, begin by turning the vehicle to the on mode, which powers the vehicle electronics without starting the engine. Next, use the HDS, Honda Diagnostics System, to clear the DTC, allowing you to see if the code reoccurs during testing. After clearing, start the engine and allow it to idle while holding the RPMs at 3000 without load until the radiator fan activates. This will help in stabilizing the engine and ensuring it reaches operating temperature. Following this, select the EGR test in the HDS inspection menu, which will help determine the current functioning state of the EGR system. This initial verification of the problem is essential in tracing the potential root cause of the DTC. Continuing with the troubleshooting process, the second step involves determining the potential failure area related to the EGR system. Start by turning the vehicle to the off-lock mode. Then switch it back to the on mode to prepare for diagnostic checks. At this stage, you will need to check the EGR valve position sensor parameters using the HDS. Specifically, you will be interested in the signal values, ensuring they match the expected threshold. If the current conditions align with the set threshold, it indicates that the EGR valve position sensor is functioning correctly, allowing you to proceed to the next troubleshooting step. Conversely, discrepancies could point to wiring issues or sensor malfunction, which will need to be addressed. For the third step, turn the vehicle to the off-lock mode again. After this, disconnect the EGR valve 5P connector to inspect the wiring and voltage output. With the connector disconnected, turn the vehicle back to the on mode to measure the voltage between the specified test points. The test points will include EGR valve connector number 2 and body ground. The expected voltage should be around 5.0 volts. If this voltage is present, it suggests the wiring from the powertrain control module PCM to the EGR valve is functional. Should the voltage readings be below this threshold, it indicates a need to investigate further, leading to the next troubleshooting steps focused on wiring integrity. In step 4, the focus shifts to ensuring no open circuits exist in the VCC1 line. After turning off the vehicle again, you will need to jump the SCS service check signal line using HDS and wait for over 1 minute. Following this, disconnect the PCM connector C 51P, as this will help isolate the component for testing. You will then measure continuity between two specific points, the EGR valve connector number 2 and the PCM connector C number 32. This checking is crucial, as continuity ensures that the wiring is intact and allows the proper signaling current to flow. If continuity is confirmed, proceed to the next step. If not, repairing the open in the VCC1 wire will be necessary. For the fifth step, you will again turn the vehicle to the off-lock mode to prepare for testing the EGRL, exhaust gas recirculation low line. As in the previous steps, jump the SCS line with the HDS, giving it a moment to stabilize. Next, disconnect the PCM connector C 51P to enable precise continuity testing. You will then measure continuity between 2 points, the PCM connector C number 46 and the body ground. Confirming continuity at this juncture is essential, as it indicates the absence of shorts in the wiring that would affect the EGR system's operation. If continuity is confirmed, you can move to the following troubleshooting steps, while a lack of continuity would necessitate repairing a short in the EGRL wire. In this sixth step, the objective is to verify the integrity of the EGRL wire further. Start by checking for continuity between test points 1 and 2 with the vehicle set to off-lock mode. The test points consist of the EGR valve 5P connector number 4 and the PCM connector C number 46. This step is pivotal for confirming that the EGRL wire has no opens, affecting its ability to relay information and control signals effectively. If continuity exists, then the EGRL wire is functioning correctly. If continuity is absent, you will need to address any issues by repairing the open circuit found between the PCM and the EGR valve to restore proper function. Step 7 focuses on checking the internal circuit of the EGR valve position sensor. First, ensure the vehicle is in the off-lock mode to safely proceed with the electrical checks. The next step requires you to disconnect the EGR valve 5P connector. allowing you to isolate the sensor for resistance measurement. You'll then use a multimeter to measure the resistance between the EGR valve connector number 3 and number 4. For a properly functioning sensor, the resistance should be at least 100 kiloohms. If this value is met or exceeded, the EGR valve should be replaced to rectify the issue. However, falling short of this resistance indicates further troubleshooting is needed, directing you to Step 8. In this 8th step of troubleshooting DTC P2413, you will again measure resistance within the EGR valve position sensor to further assess its functionality. Ensure the vehicle is turned off, lock, and the EGR valve 5P connector remains disconnected. Using your multimeter, measure the resistance between test points 2 and 4 at the EGR valve side. Similar to the previous check, the required reading should be at least 100 kiloohms. If the resistance value meets this criterion, it confirms that the EGR valve is functioning correctly and should be replaced if it intermittently fails. Should the reading fail to meet this threshold, it indicates a more profound failure within the sensor circuit, warranting investigation into other wiring issues or the need for a new replacement. Step 9 zeroes in on inspecting the EGR wire for potential shorts. Begin by ensuring the vehicle is turned to the off, lock mode. Next, disconnect the PCM connector C, 51P, which will help isolate the components during the continuity check. You will measure the continuity between the PCM connector C, number 13, and body ground. This test is critical for determining if there are unwanted shorts within the EGR wire that could disrupt signals sent to the EGR system. If continuity exists, repairs to correct a short circuit in that wire is necessary. Should continuity not be present, this indicates that there are no shorts in the EGR wire, allowing you to continue the diagnostic process to the following steps. In the 10th troubleshooting step, you will be checking for open circuits within the EGR line. Again, ensure that the vehicle is turned off for safety. Using a multimeter, you will check for continuity between test points 1 and 2, specifically the EGR valve 5P connector number 5 and PCM connector C number 13. This continuity check helps confirm that the EGR wire is not open, which could prevent the necessary signals from reaching the valve. If continuity is present, it confirms that the wiring is intact. In contrast, if continuity fails, this indicates an open circuit, requiring you to repair the wire between the PCM and the EGR valve to restore function. Step 11 involves ensuring that the EGR PGPG exhaust gas recirculation pressure gauge line is functioning correctly without interruptions. Start by switching the vehicle to the off-lock mode for safety. You'll then measure continuity between test points 1 and 2, which consist of the EGR valve 5P connector number 1 and body ground. Detecting continuity here confirms that there are no interruptions in the pressure sensing line, which can affect the EGR system's performance and emissions management. If continuity is verified, you can consider this wiring intact. If continuity is absent, repair efforts will be essential to address any issues in the EGR PGPG wire between the valve and the grounding point, ensuring the EGR system operates as intended. In the 12th troubleshooting step, reconnect the necessary connectors, particularly the PCM connector C, 51P. After reconnecting, conduct an operation check on the EGR valve to ensure proper function. This involves shorting terminals A and B of the EGR valve 5P connector to the vehicle's 12-volt battery positive and negative terminals, respectively. Start the engine and observe its performance during idle. If the engine stalls or runs roughly, it suggests that the EGR valve is functioning correctly, effectively mixing exhaust gases with incoming air. If no issues are noted, this indicates a need for further investigation into components or a replacement of the PCM for optimal performance. The final troubleshooting step involves cleaning the EGR system to ensure optimal performance. Start by ensuring the vehicle is in the off-lock mode before removing the EGR valve. Use a throttle plate cleaner to meticulously clean both the intake manifold EGR port and the internal passages of the EGR valve itself. Once cleaned, reinstall the EGR valve and reconnect all necessary connectors. With everything back in place, turn the vehicle to the on mode and reset the powertrain control module, PCM, using the HDS diagnostic tool. Finally, perform the PCM idle learning procedure and select the EGR test in the inspection menu to verify that the system is functioning correctly. If successful, this indicates that the system is operational. Otherwise, replacing the EGR valve may be necessary to resolve ongoing concerns. Upon completing the repairs or component replacements related to DTC P2413, conducting a thorough repair verification is essential. Begin by checking the DTC status to ensure that the code has been cleared and does not reappear. Next, confirm that the EGR system is functioning properly by observing its operation during idle and acceleration scenarios. A successful test would involve running the vehicle through various driving conditions to monitor the EGR system and general performance metrics. It is crucial to verify that no check engine light reactivates during the test drive. This holistic approach reassures the technician that the repair addressed the underlying issue effectively, while ensuring compliance with emission standards. To mitigate future occurrences of DTC P2413 and maintain optimal vehicle performance, engaging in preventive maintenance is essential. Regular cleaning of the EGR ports and the valve itself can prevent the buildup of carbon deposits, ensuring proper operation of the EGR system. Additionally, periodically inspecting the wiring and connectors associated with the EGR valve and position sensor can help detect any wear or damage before it leads to issues. Monitoring overall engine performance, specifically focusing on idling and acceleration behaviors, can provide early indicators of potential EGR system problems. These maintenance practices are crucial in preserving vehicle longevity and efficiency while ensuring compliance with environmental regulations. In conclusion, DTC P2413 signifies a critical issue with the exhaust gas recirculation system in the Honda Pilot models from 2016 to 2022, impacting engine performance and emissions. Understanding the functions of the EGR system, including its components, can aid in diagnosing and remedying issues effectively. It is vital to monitor for symptoms related to this DTC, from check engine light activation to changes in engine behavior, as timely responses can prevent more severe problems down the line. Regular diagnostics and preventive maintenance should be prioritized to ensure the EGR system operates efficiently, enhancing vehicle performance and compliance with emission standards. Adopting a proactive maintenance approach is essential in mitigating potential future DTC occurrences. Please like and subscribe to the channel. See you next time!